Alright, let's go over this problem. I first need to factor it. I look at the numerator. It's a constant. Can't factor that. I see a polynomial, x squared plus 1. Can't factor that. You might think of difference of squares or on the board. There's no b term. You could have had x squared plus 0x plus 1, but you still can't factor that. Okay, so can't factor it. Second thing I'm going to do is cancel, because there's no like terms I can't cancel. And then the last thing I'm going to do is I'm just going to set the denominator equal to 0. So I have x squared plus 1 equals 0. And we're trying to find a number that fits in here so that this will equal to all of the denominator equal to 0, and that'll be my vertical asymptote, right? So if we don't want that number, so subtract 1. And then if I take the square root of both sides, remember when you take the square root of an even, you have x equals plus or minus the square root of negative 1. Huh? The square root of negative 1 is x equals plus or minus I. Raise your hand if you got that. Okay. That basically means that this is a complex number. Let's write that. It's complex, and therefore it's not a real solution. Real solutions are on the x and y coordinates. Does that make sense? So in this problem, there is no vertical asymptotes. No vertical asymptotes. If I graph this, the graphical representation verifies that. If you graph it here, do you guys see any vertical asymptotes? No. If you put in 0 for x, 0 squared is 0, 0 plus 1 is 1, 4 over 1 is 4, so you have a y-intercept there. And your graph looks something like this. And in this problem, there is no vertical asymptote.